All right, inverse trig functions. We have used this in right angle trigonometry. Remember inverse trig functions. You use those when you are trying to solve back and get the angle. All right, so when we had right angle trigonometry and you were given some sides and they wanted you to tell what the angle was, you would use your inverse trig function. It is called, if you notice on here, they will have arc or inverse. And so on your calculators, when we did it with random side lengths, you would see on your calculator it would be written like that. It is the function above the function, right? What you're really trying to say is what value gives me this trig answer. All right? And so instead of me saying, what is the sine of 30 degrees? And you tell me 1/2, I would say, what angle gives you a sine of 1/2? And you would say 30 degrees. So when you're using your inverse trig functions, you are going to be given the trig answer, and you are looking for the angle that gives you that. All right? So recall that sine is the y coordinate corresponding to the arc length. Now for sine, they're just talking about sine here for right now. For sine, when you're doing inverse trig functions for sine, you're only going to consider the first and fourth quadrants, all right? So unless they tell you it's the whole unit circle, give me all the places, and there are going to be times when it says that, you can assume they want either the first quadrant or the fourth quadrant. Why would they do that? Well, because this kind of encompasses all the possible options for sine. This gives me all the positive options for sine. This gives me all the negative options for sine. Okay? Does that make sense? Because what's going to happen is it's going to repeat itself. Your sine values are going to repeat over here. Whatever the sine values were in the first quadrant, they repeat in the second quadrant, do they not, on your unit circle? The sine values are identical on first and second quadrant. Does that make sense? They're the same. They're both positive, right? Because we're in this top. And then they repeat here between the third and the fourth. So if it's in the fourth, it's going to be the same as it is in the third. And so they just use this range from negative pi over 2 to pi over 2. So if they have a negative trig function for sine, you're going to tell me the fourth quadrant, negative value. If they have a positive trig function sine, you're going to tell me the first quadrant, positive values. Okay, because that covers all of them. Negative pi over 2 to positive pi over 2 will cover all of your possibilities of answers for sine. All right. So the first thing we're looking at is just my inverse sines. Just my inverse sines. The notation that you will see, it will either be written like this, sine to the -1, which is what it looks like on your calculator. We're not going to be using a calculator. We're going to be using the unit circle. It's going to be that, or it's going to be written out like this, where it says arc sine. Either way, they are giving you the trig function and they're asking you for the angle measure, okay? Asking you for the angle measure. Unless it asks for degrees or unless it's a word problem, you're typically going to give me radians for these because it's negative pi over 2 to pi over 2, okay? So you're going to give me the radian measure. So this first one, the sine to the -1, meaning arc sine of 1/2. What are they asking? They are saying, go to the unit circle. If it is positive, is it going to be first quadrant or fourth quadrant for sine? First quadrant or fourth quadrant? First. So what angle in the first quadrant gives you a sine of 1/2? Pi over 6. Sine is y value. So the arc sine of 1/2 is pi over 6. What does this mean? It means the sine of pi over 6 equals positive 1/2. That's what that means. So your answer here would be pi over 6. All right, so look at this next one. Arc sine, okay, before we pay attention that it's a negative, arc sine of square root of 2 over 2. Arc sine of square root of 2 over 2. Which one gives you a square root of 2 over 2?
The third and fourth. Well,
just in general, square root of 2 over 2 is pi over 4. Yes? Okay. Because we're going from negative pi over 2 to positive pi over 2, you don't even have to worry about saying 7 pi over 4. You can say negative pi over 4. It's just going to drop you down. So if it's positive, you're going to use pi over 4. If it's negative, you're going to use negative pi over 4. Because it is negative pi over 2 to positive pi over 2. You're going to give me your negative angle there, okay?
But
so So in this case, they want us to use the first and fourth quadrant, going from negative pi over 2 to pi over 2. So you would say negative pi over 4, which is saying the sine of negative pi over 4, which means you start at 0 and go down 1/4, is negative square root of 2 over 2. That is true. So that means this is my answer. Let's look at this last one. What will give you a sine value of 3? What's my range for my sine value? What's the lowest y value on here? What's my lowest y value on the entire circle? The very lowest it goes.
-1.
-1. What's the highest that it goes?
1.
What's the problem with 3?
3 does not.
It's outside of the range for sine. So if you tried to put that in your calculator, if you put the second shift of sine of 3, as long as you are in, you should be in radians, or actually any of them in degrees as well, you should get an error.
Domain.
Yeah, domain error means you have you can't input, you have an input error.
So.
It means that's outside of your domain. Does not exist. Or you could say empty set does not, there is no answer that will give you a sine of 3.
I just said no.
All right, so for cosine, if I wanted all of my positive and negatives, I would look at the first and second quadrant, right? So in the first quadrant, that would be all my positive cosines, right? But I wouldn't want to use my fourth quadrant here because that's also positive cosines, right? X is still positive in the fourth quadrant. So to get all my positive and negative cosines, I would have you the first and the second quadrant. So this range is always going to be from 0 to pi. So you're going to use 0 to pi when you're using cosine. That's going to be your standard range unless your instructions tell you a different range, okay? If your instructions tell you a different range, then you're going to use a different range. But if it's not told, you're going to assume that they want you to use the first and second quadrant here, which means if it's a positive number, it's going to be in the first quadrant. If it's a negative number, it's going to be the angle that gives you the information in the second quadrant, okay? You can't just negate your angle for these. You have to actually see what gives you a negative here. You have to keep going past 90 degrees. So let's look at this first one. Again, the notation is the same. If you see the -1 or if you see arc, they are saying, here is the trig answer, give me the angle. So square root of 2 over 2, I know it's going to be a pi over 4, right? That's easy. This particular one is negative square root of 2 over 2. So it's going to be a pi over 4 in the second quadrant. So what is my pi over 4 in the second quadrant that gives me a cosine value of negative square root of 2 over 2? Yeah, so it's 1 pi over 4, 2 pi is straight up over 4, right? 3 pi over 4. So here this is 3 pi over 4. 3 pi over 4 is going to give me a cosine of negative square root of 2 over 2. All right? Technically, there are 2 places on this unit circle that give that to me, but they only care about right now from 0 to pi. If they wanted the entire unit circle, you would list everywhere that it gives you that, second and third quadrant. But they just want you right now to concentrate on the 0 to pi.
So
What's my problem with B? My range for cosine is also what? -1 to +1, right? So this is, that does not exist, okay? It's outside of my range, yes. All right, what gives me a cosine value of 0 if I'm going from 0? Yeah, if I'm going from 0 to pi, what gives me a cosine value of 0 is pi over 2. So that would be my answer there. All right. See why it's very important to know this guy? All right, let's look at guided practice 2. All right, so tangent will use the same as your sine, okay? Tangent's going to use the same ones as your sine, first and fourth quadrant. So if you can figure out what's going to be the positive tangent, it's going to be the same as the negative tangent, okay? All right? This is a little bit more to think about because tangent is y over x. And so the way I think about this one is if I have, like this first one, a square root of 3, then I am going to look for a y over x value that gives me a square root of 3 in the numerator. Because what happens is you keep change flip. So where is there a y value on the first quadrant that has a square root of 3 in the numerator? Which one has the square root of 3 over 2 as your y, is what I'm asking. Pi over 3, okay? So let's look, does pi over 3 work for this? So is the tangent of pi over 3 then just the square root of 3, okay? Why does this work? Well, y value is square root of 3 over 2, yes. What's the x value at pi over 3? What's the x value? 1/2. How do you divide fractions? Keep change flip. So I have square root of 3 over 2. That's a 3 over 2 times 2 over 1. What happens to those 2's? Cancel. All right. If it were the opposite, so let's say we had chosen pi over 6 accidentally. Let's see what happens with pi over 6. So if we chose the pi over 6, where it still has a square root of 3 over 2, but it's in the denominator, you end up with 1/2 divided by square root of 3 over 2, so times 2 over the square root of 3, right? Does that make sense? Keep change flip. You end up with the reciprocal of this, which is 1 over the square root of 3. So what's that going to look like when I rationalize it? Remember, I have to multiply top and bottom by this guy. So when it looks like this, my square root of 3 was in my denominator. It was in my denominator position. When it looks like this, my square root of 3 was in my numerator position. Those 2's are always going to cancel out because of the keep change flip principle. But when the square root of 3 ends up in the denominator, then you have square root of 3 over 3 because you rationalize it, okay? So if I were doing cotangent and it was square root of 3, I would say, well, where is my x going to have the square root of 3 in the numerator, okay? So if it ends up with just a square root of 3, that means your square root of 3 over 2 was in the numerator when you did keep change flip. If it ends up being square root of 3 over 3, that means your square root of 3 over 2 was in the denominator when you did keep change flip. And so that's a good way to remember which one am I talking about. So for this one, I was talking about where the square root of 3 over 2 was in the numerator position. And this is why it works. Keep change flip. Okay? So tangent's going to be a little more difficult because you have to think it's y divided by x instead of just look at the x or just look at the y. All right? Unless it's like a 0 or a 1, right? So arctangent of 1, that's going to be where they're the same. Where's my x and y value the same on my unit circle? Where's my x and y value the same? It would give me a 1. Pi over 4, right? Where would it be negative 1? Negative pi over 4. Okay? Does that make sense? 0. It's going to be 0 where my numerator or my y value is 0. Okay? It's going to be undefined where my x value is 0. And so the most difficult of the tangents are your square root of 3 over 2's. Those are the most difficult, pi over 3 and pi over 6's, remembering which is which. But everything else is simple for tangent. Pi over 4's are going to be 1 or negative 1. That's the only option. And the other guys are going to be either 0 or undefined because you're talking about 0 and 1's. Okay? Make sense? So what about this guy? Arctangent of 0. That's telling me where my numerator is 0 and my denominator is 1. So where's my y 0 and my x 1? My y is 0 and my x is 1.
At pi over 2.
That's an x of 0 and a y of 1.
Didn't see you.
Yeah, it's at 0. So 0 radians or 0 degrees, depending on which one you're talking about. Remember, tangent is y over x. Y over x. So when you do arctangent, you're saying which y over x gives me this value. Which y over x gives me this value. You're going to have to think about it more than the sine and cosine. Yeah, because the sine and cosine is just where's my y value this, where's my x value this. Tangent's a combination of the two. So go ahead and try those. Guided practice 3 at the bottom of page 283. When I'm talking about arctangent, okay, so arctangent, all right, they have given me some y over x value is what they've done, okay? So that means what's the tangent here? Well, the tangent here is going to be square root of 2 over 2 over square root of 2 over 2, right? Same number over the same number. That's going to be just 1, right? My tangent here, what's my tangent here? Well, that's going to be y over x. That's going to be 0. My tangent here, that's going to be y over x. That's going to be undefined, right? Because I have a 0 in the denominator. So if they're asking me about some tangent that deals with the square root of 3, either one of these, then I know it's going to be either pi over 6 or pi over 3. Like, those are my options for tangent. And I've narrowed it down that it's not going to be on my quadrants, like on my x-axis, and it's not going to be a pi over 4. Pi over 4s are 1 or negative 1. So now I just have to decide which it is. This guy right here means my numerator had to be a square root of 3 over 2. Because, so let's take this guy. We're going to take pi over 3. My tangent of that's going to be y over x, square root of 3 over 2 over 1/2, right? At pi over 6, that's going to be y over x. Make sense? So when I keep change flip this guy, I get square root of 3 over 2, keep change flip, I get just a square root of 3.
Okay.
When I keep change flip this guy, I get 1/2 times 2 over the square root of 3, so I get 1 over the square root of 3. I have to rationalize it, so I get that. So when I get any arctangent with a square root of 3, I have narrowed it down to a pi over 6 or pi over 3. And if it's just a pi over 3, that means my keep change flip deleted the 1/2 pretty much. The 1/2 deleted my denominator. If it's square root of 3 over 3, it means it was originally in the denominator and I had to rationalize it. Just talked about it. Square root of 3 over 3, okay? That's going to be either my pi over 6 or my pi over 3. In this case, because it's square root of 3 over 3, it means my square root of 3 was originally in my denominator or my x value, okay? So which one is going to give me that? Well, it's going to be a pi over 6. Specifically, it's a negative. What's nice about this is the same as sine. If I know it's a pi over 6, right? I know it's a pi over 6. It's just like sine. If it's negative, I can just do that. Remember, first or fourth quadrant. It's the same as my sines. I can use first and fourth. All right, -1. This is going to be on an axis, right? On an axis, potentially. I mean, it's going to be on a pi over 4, right? Because they're the same value. Same value over the same value will always give me a 1, right? Which one has an x and y that's the same value? What has an x and y of the same value?
Pi over 4.
Pi over 4 has the same value. And remember, we're first and fourth quadrant, so as long as you figure it out, it's negative, you can just negate it. Negative pi over 4. For sine and for tangent, as long as you figure out what gives you the value, and you can just negate it. You can just go down. All right? if you take, so let's go back to this. Remember when you did composite of functions and you could prove it was a composite by saying it equals x? Do y'all remember that? So if you'd had two functions, one of the ways you could tell if they were inverse is if you did composite, you should have gotten x by itself. Okay, x by itself. And so this works the same. When we do this with trig functions, it seems somewhat like you haven't done any work because they're really simple. Look at this first one. They want to take the sine of the inverse sine of negative 1/4. Right? So this seems kind of counterproductive. But what they're saying is, does this exist? All right. So is this in the interval? First of all, is negative 1/4 in my domain of sine? What's my domain of sine? What can it be? From what to what? For sine, what's my lowest value? Lowest value of sine? Negative 1 to my highest value of 1. Okay? Is negative 1/4 in that range? Yes. Negative 1/4 is between negative 1 and 1. Does everybody agree with that? Everybody agree that negative 1/4 is in between here? Yes. So basically what happens when it falls in the correct domain is if I take the sine inverse and then I take the sine, I just get what I started with. It's like taking the square of a square root. You just get what you started with. So the answer here is just negative 1/4. If I take these two, basically cancel each other out as long as that guy is in the right range. Now, if they had said 2 in there, I would have said that's not going to work because 2 was never going to work to begin with, right? But it does work. It works here. All right? Let's look at this next one. Does this work? First of all, what is my tangent? My tangent's y over x. What's the problem with the tangent of pi over 2? Does it exist? It doesn't. So these will not cancel each other out because we already have a problem with this guy. He's where one of my dotted lines were, right? My x value is 0 at pi over 2. Anywhere my x value is 0, I do not have a tangent. So this guy's outside the range. That does not exist. They will not cancel each other out there. Okay? Let's look at this last one. And I'm going to do this a little differently than the book does. Does the sine of 7 pi over 4 exist? Well, yes. The sine of 7 pi over 4 exists. That's a correct domain. I can put that into sine, right? So that means it exists. These are going to cancel each other out, and you can say 7 pi over 4. All right? And I'm going to allow you to use 0 to 2 pi for these. The book's going to tell you just to give them negative pi over 4. I'm not going to make you do that. All right? As long as it exists in the domain, you can just give me what the value is all the way on the inside. All you're having to determine is, does it work on the inside? Is the inside part of the arctangent domain or is it part of the original domain? Then yes, they're going to cancel each other out. Okay? So when you do an inverse with its function, they cancel each other out as long as there's not a problem already built in there. Okay? As long as there's not a problem. If they had said something like this, sine of the inverse sine of 2, we would have a problem because this guy is outside of my domain of negative 1 to 1. And you would say, nope, it doesn't exist. But as long as what's on the inside works, those two functions are going to basically cancel each other out. It's like adding and then subtracting the same number. Nothing changes. Okay? Inverse functions will cancel each other out. It's like when we did logarithms. An exponent bases canceled out our log bases. It's the same thing. Add this one. Does the cosine of 3 pi over 4 exist? Yes, it exists. It's negative pi over 2. Square root of 2 over 2, right? Right? So as long as it exists, these two cancel each other out. If I were to do, what's going to happen here is, if we worked the inside out, like let's say we worked the inside out here. Let's say I took the cosine of this guy. That would give me negative square root of 2 over 2. And then I took the inverse. That's going to give me 3 pi over 4 potentially, right? So if it works, then these two just cancel each other out, and your answer is what was there to begin with.